I give this exercise to my students in my face-to-face class. I ask them to sketch the graph of the equations. Here I have added the graphs for you to see. Then I ask them to complete the table using the value of big D and the number of x-intercepts found in the graph to make a conclusion that I will explain shortly. You may want to pause the video here to see if you can make the correct conclusions before continuing the video. I like using the discriminant to predict what I should expect when using the quadratic formula. I also like to use it to let me know what the graph will look like. For example, if big D is positive, I know I will get two real solutions. Rational or irrational does not matter, and this means that the graph will have two x-intercepts. However, if the solutions were rational, then the equation was actually factorable, which means I could have factored the equation to find the x-intercepts. The reverse is also true, that if the solutions were real but irrational, I would not be able to factor the equation. If big D is 0, I know I will get one real rational solution, and this means that the graph will have one x-intercept. This means that the vertex of my graph will be on the x-axis. The graph can open up or down, since that depends on the value of a, the coefficient of x squared. This is what we learned in Unit 2 about vertical reflections. If big D is negative, I know I will get two complex solutions, and this means that my graph will never touch or pass through the x-axis. This means that the vertex of the graph is either above the x-axis and opening upward, or the vertex is below the x-axis and opening downward. In either case, the graph stays away from the x-axis. The conclusions are that if D is less than 0, the graph will not have x-intercepts and will not touch or cross the x-axis. If D is equal to 0, the graph will only touch the x-axis and have one x-intercept. And if D is greater than 0, the graph will cross the x-axis twice, and it will have two x-intercepts.